This is 10L. We're going to do question 3 and we'll do question 4. Okay, question 3. So this is in two different places here. We've got question 3 here and over here as well. So this one is a ladder rests along against a vertical wall. So let's just draw this situation here. We've got this situation here and we've got 4 meter ladder. And it's talking about the bottom of the ladder sliding away from the wall. So we're interested in this length here. Then it says, find how fast the angle between the ladder and the wall. So let's just set this up. There's our theta over there. Okay, and that's obviously a right angle triangle as well. So there's our little sketch. So it says, find out how fast the angle between this ladder and this wall will be changing when the angle is pi over 3 radians. Don't worry too much about the radians measurements. Essentially, if you want to change radians back into degrees, you can times by 180 over pi. We'll deal with radians in a bit more depth later on, of course, but just to know that differentiation only works with trigonometry when we have radians, not when we have degrees. So if you wanted to, in fact, figure out what they're talking about here, pi over 3 radians, well, pi is 180 degrees. And so pi over 3 would be 60 degrees. So that's what they're interested in. Get 60 degrees. Okay, so clearly we need to have a theta involved in some formula here. And I can see that I have the hypotenuse and I have the opposite involved. So I could set up, in this right angle triangle, I could set up sine of theta is equal to x over 4. Okay, now it wants how fast the angle between the ladder and the wall will be changing. So they're looking for this, they're looking for d theta dt. Now let's just split that one up. We've got d theta dt. We've got this other thing which is involved. We've got x which is involved in this problem as well, which is what we created. So let's put in a dx and a dx there as well. How fast this will be changed. So we know theta is equal to pi over 3. Okay, and this information here, this 1.5 meters per second, that's how x is changing with respect to time. So you can see that we have this thing already. That's our 1.5. Okay, so we need to find out d theta dt, this thing here. So we're going to find out d theta dt. Sorry, d theta dx. And well, the problem that we have is that we don't have theta is equal to something. We could do sine to the minus 1, but we don't know how to differentiate sine to the minus 1. So what we're going to do instead is we're going to change this to 4 sine theta equal to x, and then we're going to work out the x, the theta instead. Okay, so x was where you'd normally write y there. Okay, so if you do this one, sine becomes cosine, so you can say 4 cosine of theta there. Now that means to say that d theta dx, we're allowed to do this with differentiation. This was a note before the exercise. You can do d theta dx. You can take the reciprocal of the function which we've got over here. But we've got 4 cos theta there. Okay, now we have everything which we need because, of course, we have this to go in here. And now you can substitute in for theta into this thing here. We can substitute in the 1.5 into this thing here as well. And we are sorted. The question will be easy from there on. Okay, right. Now I'm just going to do question 4 as well. I think that's all I have time for. And I'll come back and I'll do the other ones later. So question 4. Okay, so this is talking about a water trough and something like this. Looks something like this. and it's 4 meters long. Now I'm going to change everything into centimeters. I can see they're asking about centimeters later on, so I'm just going to change this into 400. And it says as well that the base length is 1 meter for this isosceles triangle. So it's our isosceles triangle. So this is 100 centimeters there. And we're also told that we have a height of this of 120. Okay. It says that the trough is being filled at a rate of, so the trough is being filled, so filling it is the volume, and that's happening at this 120 cubic centimeters per minute. And what we're looking for is how fast, so how fast the water level will be rising. So that's the height. Water level will be rising. And that how fast means a rate again. So it's with respect to time. So that's dHdt that we're looking for. Now, dHdt, let's just split that up again. So dHdt. Now, we definitely know that we have dVdt because that's going to go into there. So dV is our other variable there. V is the other variable. So we're going to need to work out dH dV or dVdH, one or the other. Now, I think it's probably going to be easier to work out dVdH because we can work out a formula for the volume. Now, the volume is equal to the area of the front face to start off with, and then times by the 400. So let's just use the area of the front face, and that's a half base times the height. Now, you might think that the height is 120 centimeters, but the volume of the water is increasing as we go through. It could be here, it could be here, it could be here. And how fast the height is changing at any point is dependent on where we are in terms of that height. So then you might think, well, the 120 is completely irrelevant. Why do we need it at all? Well, we need it because it gives us the ratio of our base to our height. So there is a multiplier between those two numbers. And that's always going to be the same multiplier because you always have similar triangles as you go upwards as this thing fills. So the multiplier, in fact, is equal to, you can see that we're going to times by 5, 5 by 6. Okay, obviously you can do that on your calculator, 100 divided by 120. So that's times by 5 over 6. In other words, we have this. The base, let's figure out which way around I need this. The base is equal to, 5/6 of the height. And I'm going to replace that in here. I was just thinking for a moment there because I wondered, what do I need in my formula? Do I need all H's or all B's? In fact, I need all H's, so I need to replace my B with some formula for H. So if I put that in, a half times 5/6 gives us 5/12, and then times by, so B, 5/6 times H, so I'm going to put the H in, and there's another H there, so H squared. Now I'm just going to change this into volume as well, so volume is that times by 400. Now, if I multiply that out, I should get 500 over 3 H squared there. So that's V in terms of H. Now it's pretty straightforward. So we can now say dV dH, and that's equal to 1000 over 3H. So all I've done is times by the 2 and reduce the power by 1. And now, of course, we can take the reciprocal of this. So the H dV is going to be equal to 3 over 1000 H. Okay, now, so we've got all of the information, just gone to there, we took the reciprocal. So now we've got this can go in for this, and this can go in for this, and we can put in the 45 centimeters for H as well. Okay, guys, thanks for listening. Just a couple of points on questions 5 and 6, though. I will go through these later on. If you're struggling through for these ones, you essentially need for question 5 the area of a segment formula. In fact, I'll give you that now. Okay, so let's just clear all of this out. Okay, so the area of a segment formula, which I'll explain later on, but that's equal to a half r squared theta minus a half, so let's just take that back, half r squared sine theta. That's the area of a segment. Okay, so you're going to need to use that formula for question 5. Yeah, and question 6, similar sort of question using trigonometry as well. I'll go through that later. Okay, thanks for listening, guys.